Let's start the questions of today on question 37. Number I is asking explain the gas laws by using equations. As answer, the gas laws consist of three primary laws. The first law is Charles' law, the second one is Boyle's law, and the third law is the Avogadro's law. And these three laws they get combined into one law that we call the ID gas law. Starting with Boyle's law, according to Boyle's law, at constant temperature, the volume has an inverse relationship with the pressure. With the Charles' law, the volume is directly proportional to the temperature at constant pressure. So when you have at constant pressure, according to Charles' law, the volume is proportional to the temperature, and this B is a proportionality constant. According to Avogadro's law, the volume is proportional to the number of mole at constant pressure and the constant temperature. If you have a constant temperature and a constant pressure, the volume will be proportional to the number of mole, and that A is the proportionality constant. When you combine these three laws, we will get the ID gas laws, where the volume is proportional to the number of mole according to Avogadro's number, and it is also proportional to the temperature, and it is inversely proportional to the pressure, as we have seen in the different laws. If then we can arrange this equation where V or volume is equal to L as the proportionality constant or gas constant times N times the temperature over pressure, that means that pressure times volume, PV, will be equal to nRT, or the number of mole times the gas constant times the temperature. Then that means that pressure times volume over the number of mole times the gas constant times temperature, it will be equal to constant. In the equation above, when you have the ID gas law, we have different important parameters, and the parameter to consider, we have the pressure, we have the volume, we have the temperature, and the number of mole. So if you know 3 out of the 4 parameters in the equation, you can determine the fourth one. Then this ID law, ID gas law, is also used to calculate the change that occur when you change the condition. For example, when you are changing the pressure, you change the volume, you see you can calculate the what will happen on the other parameter, like the number of mole. Or you can change the temperature, and then you will see what happened to the volume, or you calculate what is happening to the change in volume. The good advantage also for this ID gas law is that you can use it for any question regarding the Boyle's law, regarding the Charles' law, or regarding the Avogadro's law. So it combines all these three questions regarding the calculation of the questions that deals with the Boyle's law, the Charles' law, and Avogadro's law. You can use this ID gas law equation to calculate these kind of questions. The second sub-question of this question 37, consider a 1.53 liter sample of gaseous sulfur dioxide at the pressure. So the pressure was given. If the pressure is changed, so if it is increased, if the pressure is changed at a constant temperature, what will be the new volume of the gas? So now the temperature is constant, and we are changing the pressure, and they are asking to calculate the volume. Here we can use the Boyle's law to calculate this kind of question, or you can use the ID gas law. Using the Boyle's law, we know V, or the volume, is has an inverse relationship with the pressure, and that is the proportionality constant. It will give us PV, the pressure times the volume, is equal to the constant. That means that P1 V1 is equal to P2 V2. We have P1, which is 1.53 liter, and you have the volume we have V1, the volume 1, which is 1.53 liter. We have also the pressure, which is P1, which is 5.6 times 10 power 3 Pascal. We have the second pressure after changing the pressure, which is 1.5 times 10 power 4 Pascal. Then we need to calculate the volume, which is the second volume after changing the pressure. Then after replacing the values, we calculate V2 and we obtain 0.57 liter as the new volume after changing the pressure. Number 3, I as a sub-question, we have the result in the table which indicates the pressures and the temperatures for 1 mole of ammonia gas, and this 1 mole of ammonia gas was measured at the 0 degree Celsius, so that means at 273 Kelvin. They are asking to calculate the Boyle's law constant for ammonia at the various pressures. So we have a pressure and we have the volume, and we have to calculate the Boyle's law constant. And we know the Boyle's law constant is equal to the pressure times the volume, which means we'll be taking the pressure in this table times the volume to get the constant. That means we take 0.13 times 172.1 to get the first value, and so on. So after doing so, I will get the column, the last column in the table, which is indicating the constant, they calculate the constant for each value of pressure and volume. Next question, a sample of gas at 15 degrees Celsius and 1 atmosphere has a volume of 2.58 liter. What volume will this gas occupy at that 8 degrees Celsius and 1 atmosphere? Here we have a gas at 15 degrees Celsius and 1 atmosphere, which means we are having the temperature and the pressure, and you have the volume, which is 2.58, and now they are asking what will be the volume of this gas if we are changing the temperature from 15 degrees centigrade to 8 degrees Celsius and 1 atmosphere. So here we will use the Charles law because we are having the constant pressure. At constant pressure, the volume of the gas is proportional to the temperature. That is V, which is the volume, which is proportional to the temperature at constant pressure, and this B, that is the proportionality constant. That means that when we take a V over T, and with that T we get the constant B, or the proportionality constant, and that means that V1 over T1 is equal to V2 T2, and the volume 1 we have which is 2.58, and the temperature 1 we have 15 degrees Celsius. We need to convert this 15 to Kelvin, so we will add 15 and we add 273, and then we get, after adding 15 to 273, we will be obtaining 288 Kelvin. And then V2, that's what we need to calculate, and we have also T2, the temperature change. They have changed the temperature from 15 to 38. That means that 38 degrees Celsius, we need also to change it to Kelvin by adding 273 K. Then after adding 273, then we will get 311 Kelvin. Then that means that after replacing the values, we calculate V2 and we get 279 liters. So that you can see that we are changing the temperature, and if you change the temperature, we expect the increase in the volume. So we are having 258 liter. Now we are having 2.79 liter. So the volume is increasing because we have increased the temperature. Next question, suppose we have a 12.2 liter sample containing 0.5 mole of oxygen gas at a pressure of 1 atmosphere and a temperature of 25 degrees Celsius. If all of this oxygen were converted to ozone at the same temperature and pressure, what will be the volume of ozone? Explain why the volume decrease. So here they are converting the oxygen, they have more of oxygen, and they are converting to the ozone. So that means that the first a mole, we have, this is for oxygen, we don't know the mole of ozone that will be produced, so we need to find out the mole of ozone, and that will be N2. So then, because we are dealing with the number of mole and we have the other parameters, we have temperature and pressure, which is constant. In that case, then you can use the Avogadro's law. For a gas at constant temperature and pressure, the volume is directly proportional to the number of moles. So that means that V is equal to N times A, which is the proportionality constant. Then after, we can then arrange the formula. That means that V over N is equal to the constant, or the proportionality constant, and that means that V1 over N1 equal to V2 over N2. And the V1, that is the volume 1, and the N1, that's the number of mole 1, and the V2, that's the volume 2, and the N2, that is the number of mole, the second number of mole. For this one, we have V1 we have, and N1 we have, because we have the moles of oxygen, which is 0.5 moles, and you have the volume that they occupy, which is V1, which is 12. It was given as 12.2 liter. And then for N2, we need to find the moles of ozone, which will be produced from the balanced equation. So after balancing the equation, we know that 3 moles of oxygen produce 2 moles of ozone, then 0.5 mole of oxygen, they will produce 0.33 mole of ozone. Then we will be having also N2. Then we determine V2, and we obtain V2, which is equal to 8.052 liter. So you can see that the volume decreased. Of course, that is because after changing the oxygen to ozone, the number of moles decreased. We were having 0.5 mole of oxygen, and at the end we produce 0.33 mole of ozone. So we have the number of moles which is decreasing. So decreasing the number of moles should also decrease the volume. Next question, a sample of hydrogen gas has a volume of 8.56 liter at a temperature of 0 degrees Celsius and a pressure of 1.5 atmosphere. Calculate the moles of hydrogen molecule present in this gas sample. So what do we have here? We have a sample of hydrogen, and we have its volume. That is the one parameter we have. We have the temperature, that's the second parameter. We have also the pressure, that's the third parameter. Then we can calculate the number of moles which is required. Calculate the number of moles of hydrogen present in gas sample. So in that case, then you can calculate the N. So because we know from the ideal gas equation that PV is equal to N times the gas constant times the temperature, then this means that the N is equal to pressure times the volume over gas constant times the temperature. So then, replacing the value that we have, the pressure of 1.5 atmosphere, the volume 8.56 liter, and the gas constant, and the temperature, which is changed in Kelvin, then we will obtain 0.57 moles. Next question, suppose we have a sample of ammonia gas with a volume of 7 milliliter at a pressure of 1.68 atmosphere. The gas is compressed to a volume of 2.7 milliliter at a constant temperature. So here the temperature is constant. Then use the ideal gas law to calculate the final pressure. So that means that we need to use the equation, which is PV is equal to NRT. We know that PV dividing with NRT will be constant. That means that P1 V1 over N1 L1 T1 will be equal to P2 V2 over N2 L2 T2. After then, we can see which parameters are constant in this equation. The pressure the pressure is not constant, because we have the pressure we have the first pressure, which is 1.68 atmosphere, and we have P2 that we need to calculate, because they are asking what will be the pressure, the final pressure, which will be P2, and the V1. We have V1, which is 7 milliliter, and you have V2, which is 2.7 milliliter. That means that the volume is not constant. The number of mole is constant. N1 will be equal to N2. The gas constant is also constant. L1 will be equal to L2, and the temperature is also constant according to the equation. They are telling us that it is at constant temperature. So that means that the values which are constant, you can eliminate them from the equation, because N1 will be cancelled with N2, L1 will be cancelled with L2, and T1 will be cancelled with T2, because they are constant, they will be equal. Then in the equation remaining with P1 V1 is equal to P2 V2, then we determine P2, which will be equal to P1 V1 over V2, and replacing the values, we get the final pressure, which is 4.36 atmosphere. We have another question where a sample of methane gas that has a volume of 3.8 liter at 5 degrees Celsius is heated to 86 degrees Celsius at constant pressure. Calculate its new volume. So again, we need also to use the ID gas law equation, where we have P1 V1 is equal to N1 L1 T1. Then we have P1 V1 over N1 L1 T1, which will be equal to P2 V2 over N2 L2 T2. Then we check the parameter which are constant. So pressure is constant, because they are telling us that at a constant pressure, that means that P1 will be cancelled with P2, the number of mole will be constant, N1 will be cancelled with N2, the gas constant also we cancelled because they will be equal. We remain with V1 over T1 equal to V2 over T2. Then V1 T2 will be equal to V2 T1, and then we calculate V2, which will be equal to V1 T2 over T1. In that case, after replacing the value that we have, we will get 4.9 liter as a new volume. Next question, that's the number sub question 9. A sample of diborane gas, a substance that bursts into flame when exposed to air, has a pressure of 345 torr at a temperature of minus 15 degrees Celsius and a volume of 3.48 liter. If the conditions are changed, so that the temperature is 36 degrees Celsius, so they are changing the temperature from a minus 15 degrees Celsius to 36 degrees Celsius, and the pressure is changed from 345 torr to 468 torr. What will be the volume of the sample? So the pressure is changing, the volume is changing, and the temperature is changing. The area is constant, the number of mole is constant. Then we can do the same and cancel the parameter which are constant, because they will be equal. Then P1 V1 over N1 L1 T1 is equal to P2 V2 over N2 L2 T2. Then number of mole will be constant, it will be cancelled with N2. The L1 will be cancelled with L2. Then we remain with P2 V2 over T2, which will be equal to P1 V1 over T1. Then in that case, we can arrange the terms. Then to get the volume which is asked, we are asked to calculate the V2. V2 will be equal to P1 V1 T2 over P2 T1, and then after replacing the values, we will get 3.07 liter as the second volume, as V2, the new volume, will be 3.07 liter. Sub question 10, a sample containing 0.35 moles of argon gas at a temperature of 13 degrees Celsius and a pressure of 568 torr is heated to 56 degrees Celsius. Then they are changing it. This means that they are changing the temperature from 13 to 56 degrees Celsius, and the pressure, they are also changing the pressure that calculates the change in volume that occurs. So we also use the same logic. We know P is equal to nRT, and now we have the volume which is equal to nRT over P. Now they are asking to calculate the change in volume. So that means that we calculate the volume before changing and the volume after changing, then we do the difference. Then we need also to convert the torrs to atmosphere. We are by converting the torr to atmosphere, we divide it for 760. Then we get 0.747 atmosphere and 1.18 atmosphere after changing the pressure. So we calculate the volume before heating, so that will be volume is equal to nRT over P. We obtain 11 liter. We calculate the volume after heating, we also obtain 8 liter. Then the change in the volume, that will be the difference. Then it will be 8 liter minus 11 liter, we obtain minus 3 liters as a change in volume. Next question is asking to prove that at STP, 1 mole of an ID gas occupy a volume of 22.4 liter. For this one, we know at stand temperature and pressure, the temperature is 273 Kelvin and the pressure is 1 atmosphere. Then we calculate the volume that occupied by 1 mole of gas. So that means that we replace N by 1, the gas constant, it will stay constant. The temperature at STP it will be 273 Kelvin. The pressure at STP is 1 atmosphere, and we will see that really at the STP 1 mole of ID gas occupy 22.4 liter. Next question, a sample of nitrogen gas has a volume of 1.75 liter at STP. How many mole of N2 are present? So there we calculate the number of mole. We know PV is equal to nRT. N is equal to PV over RT. We have the pressure at STP. We know the pressure is 1 atmosphere. The volume was given 1.75. The gas constant, the temperature we know at STP is 273 Kelvin. Then replacing the values, we obtain 0.078 mole. Or you can take at STP, the number of mole is equal to the volume dividing with the molar volume. So the molar volume is that is the volume that 1 mole of gas occupied at STP. So you can also take V dividing with Vm, and you will get also the same answer if you are determining the number of mole at STP. Next question, quicklime calcium oxide is produced by the thermal decomposition of calcium carbonate. Calculate the volume of carbon dioxide at STP that will be produced from the composition of 152 gram calcium carbonate by the reaction. So the reaction is given, so that means that the calcium carbonate is decomposed to calcium oxide plus calcium plus carbon dioxide. That means that we can calculate the number of mole of carbon dioxide produced from 152 gram of calcium carbonate. But we need first to find the number of mole of calcium carbonate. So the number of mole of calcium carbonate will be equal to 152 gram, which is the mass dividing with the molar mass. The molar mass of calcium carbonate is 100. Then we get 1.52 moles. Then from the equation we know 1 mole of calcium carbonate produce 1 mole of carbon dioxide. That means that 1.52 moles of calcium carbonate they will produce also 1.52 mole of calcium of CO2. So the moles are the same. Then after getting the number of mole of carbon dioxide, then we calculate the volume. We know the volume is equal to nRT over P. Then we replace the number of mole, the gas constant, the temperature and the pressure, and we will obtain 34.05 liter. After getting the number of mole also, because we are at STP, we can calculate the volume by taking the number of mole times the Vm, which is the molar volume, the volume occupied by 1 mole of gas at the STP. So you also obtain the same answer. A sample of methane gas having a volume of 2.8 liter at 25 degrees centigrade and 1.65 atmosphere was mixed with a sample of oxygen gas having a volume of 35 liter and at 31 degrees Celsius and 1.25 atmosphere. So we are mixing methane and oxygen. The mixer was then ignited to form carbon dioxide and water. So that means methane gas reacted with oxygen to form carbon dioxide and water. What will be the limiting reactant? How many more will be in excess? Calculate the volume of carbon dioxide formed at the pressure of 2.5 atmosphere and at a temperature of 125 degrees Celsius. Here, if now we are determining the limiting reactant and the excess, because the carbon dioxide which is produced depend on the limiting reactant amount. So we need to find between methane gas and the oxygen which will be the limiting reactant. But before doing so, we should know what amount of methane gas and what amount of oxygen reacted. So we need to determine first the number of mole of methane gas and the number of mole of oxygen. So PV is equal to nRT, N is equal to PV over RT. We can calculate the mole of methane gas. We obtain 0.189. We also calculate the mole of oxygen. We obtain 1.75 0.54 moles. And then we see that the balanced equation, according to balanced equation, 1 mole of methane gas react with 2 moles of oxygen. Now, this 0.189 mole of methane gas, they will react with 0.378 mole of oxygen. So you see that all the oxygen will not react, only 0.378 mole of oxygen will react. So then we will know that because the oxygen will be in excess, the methane gas will automatically become the limiting reactant. The oxygen will be in excess. We calculate the amount of excess of oxygen by taking 1.754 moles of oxygen which were present minus the one reacted, which is 0.378 mole, and we obtain the excess mole of oxygen, which is 1.376 mole of oxygen. So now, after getting the limiting reactant as methane, then we can use it to calculate the amount of carbon dioxide produced. Since according to the equation, 1 mole of methane gas produce 1 mole of carbon dioxide, that means that 0.189 mole of methane, they will also produce 0.189 mole of carbon dioxide. So after getting the mole of carbon dioxide that produced, then you calculate the volume that they will occupy. So the volume is equal to nRT over P. Then we get 0.189 moles times the gas constant times the temperature. The temperature was given, but we have changed to Kelvin, dividing with 2.5 atmosphere. Then we will know the volume that this number of mole of carbon dioxide will occupy, and we will get the volume of 2.47 liters. Next question, the density of gas was measured at 1.5 atmosphere and 27 degrees Celsius, and it was found to be 1.95 gram per liter. Calculate the molar mass of the gas. So we know that the number of mole is equal to mass over molar mass. We know that PV is equal to nRT. So that means N is equal to PV over RT. So then the PV over RT is equal to mass dividing with the molar mass. Then we can determine the molar mass, and we see that the molar mass equal to mass times the RT over PV, and then mass over the volume, that is the density. That means that molar mass is equal to density times the gas constant times the temperature over the pressure. Then we can replace the values to get the molar mass, and we will get the molar mass, which is equal to 32 grams per mole. That was the end of this presentation. We will see the next series of questions next time, where we will see also the question regarding the calculation of gas pressure, temperature, and the number of mole and the volume that they occupy.